Imagine knowing exactly what you'll be doing tomorrow, right down to the last detail, every thought, every move, every tiny decision. Sounds both thrilling and terrifying, doesn't it? But what if I told you that in our universe, this perfect foreknowledge isn't just practically challenging, it might be fundamentally impossible? This is computational irreducibility. At first glance, computational irreducibility sounds like something only mathematicians would love at parties, but it's simpler and way more profound than it sounds. Think of it this way: if a system is computationally irreducible, predicting what it'll do next isn't just hard, it's literally impossible to shortcut. You have to watch it happen in real time, step by step, moment by moment. Picture rush hour traffic, predicting average speed. Easy enough. Engineers have formulas for that, but exactly which car will be right beside yours at precisely 3:47 p.m. No formula can tell you that. To know, you'd need to watch every single driver's every tiny decision as they happen. The traffic itself is running a computation. It's in real time, and there's simply no fast forward button. That's computational irreducibility. And it's not just about traffic, it's everywhere. Take weather forecasting. We all joke about meteorologists getting it wrong, but here's the catch: they can't always get it right. Tiny differences, like a butterfly flapping its wings, can spiral out of control, making accurate long-term weather predictions impossible beyond about 2 weeks. Even a supercomputer the size of Earth simulating Earth's weather in perfect detail wouldn't predict future weather faster than reality itself unfolds. Nature already computes at maximum speed, and no shortcut exists. This irreducibility also pops up in something called the three-body problem in physics. Two objects orbiting each other, easy math. Add just one more body, like the Earth-Moon-Sun trio, and the mathematics collapses into chaos. We literally cannot predict their exact positions far in the future without simulating every single step. No neat equations, just pure unfolding chaos. And speaking of chaos, ever played Conway's Game of Life? Simple grid, simple rules, yet shockingly complicated results. Predicting the pattern after a million generations isn't possible without running every single one of those million steps. Simplicity doesn't guarantee predictability. Now, let's get philosophical, because this isn't just math. It shapes how we see ourselves in our universe. If irreducibility is fundamental, then the universe is inherently unpredictable. Even with infinite intelligence, you'd still have to wait and see what happens next. Think about what this means for determinism, the idea that everything is predetermined. Irreducibility suggests a universe that creates genuine novelty with every passing moment, reality that continuously invents itself. But what about AI? Can't computers eventually predict everything? Here's the uncomfortable truth: even the smartest AI can't cheat irreducibility. Suppose an AI tries predicting the stock market with perfect accuracy. The moment it makes predictions and acts on them, it changes the market itself, destroying its own predictions. That's because the stock market isn't just numbers, it's a real-time computation by billions of people interacting constantly. In fact, this insight should humble our grand dreams of superintelligent AI gods. No matter how smart they get, AIs will still face irreducible limits. Some futures, some events, are simply locked behind the universe's ultimate speed limit, the speed of real-time computation itself. Now, what does this mean for us humans? Well, if you've ever felt like some problems can't be solved with neat equations or spreadsheets, welcome to reality. Complex issues like economies, societies, ecosystems, they all contain irreducible elements. This doesn't mean giving up, it means embracing uncertainty, adaptability, and experimentation. For policymakers, this highlights the danger of trying to control everything with a simple top-down model. Complex societies aren't math problems to solve. They're ongoing, dynamic experiments to participate in. So rather than striving for complete prediction and control, computational irreducibility nudges us toward a mindset of curiosity and resilience. It teaches us to navigate uncertainty gracefully, recognizing that surprise isn't a glitch, it's the very nature of reality. And here's something even more intriguing. What if our consciousness, our free will, our creativity all emerge from irreducible computations happening right now in our brains? Maybe your next thought isn't written anywhere. It genuinely emerges in real time, unpredictable, even by the universe itself. Could irreducibility be the secret sauce behind human spontaneity? Stephen Wolfram, the scientist who introduced computational irreducibility, certainly thinks so. He argues boldly that our universe isn't fundamentally built on elegant equations, it's built on computations. Those computations, simple in rule yet infinitely complex in consequence, give rise to all the wonder and messiness we see, from galaxies spiraling in space to neurons firing in your brain. The universe unfolds step by step, moment by moment, utterly irreducible. At heart, computational irreducibility tells us something beautiful and unsettling. Perfect knowledge is impossible. Even a hypothetical cosmic intelligence with infinite intellect would have no cheat code to skip ahead. To know tomorrow, you have to wait for it. And there's something deeply comforting in that unpredictability. It means novelty, creativity, and genuine surprise aren't illusions. They're fundamental aspects of existence itself. So maybe tomorrow isn't fixed at all. Maybe the universe, rather poetically, refuses to spoil its own story. Each of us participates in an ongoing, open-ended computation, an adventure whose next chapter is always genuinely unwritten. In a universe like that, unpredictability isn't just something we endure, it's something we celebrate. It gives meaning to exploration, discovery, and the thrill of waking up each day to genuinely unsure of what happens next. So